Hello everybody, my name is Thomas Block. I am Senior Product Manager at Bosch Sensortech for environmental sensors. Today I will talk about accurate indoor localization can save thousands of lives, enabled by pressure sensing solutions. Here is my agenda. First, I will talk about GPS in general and what's the issue when it comes to vertical localization inside buildings using GPS. Then I will talk about the FCC initiative for E911 calls in the US and the usage of barometric pressure sensors for accurate indoor localization, because that may be a surprise that only pressure sensors can help here. Finally, I will give a summary of my talk with an outlook. So GPS and vertical localization inside buildings. What is this about? So normally you know GPS from smartphones, for example, for outdoor navigation. This is a traditional solution. So the Global Positioning System, short GPS, as a satellite-based radio navigation system, is one of the global navigation satellite systems, called GNSS, that provides geolocation and time information to a GPS receiver anywhere on or near the Earth, where there is an unobstructed line of sight to 4 or more GPS satellites. With over 4 billion mobile devices deployed with integrated GNSS, personal location is available to the mass market worldwide, and the number of GPS sensors in smartphones are increasing every year. So GPS is good at determining the user's location, but only when the GPS signal is not blocked. Unfortunately, GPS is not very accurate when it comes to altitude estimation, especially in urban areas, forests, or even just on a cloudy day. It is either hard to obtain a GPS signal at all or achieve a reasonable vertical accuracy. This is for outdoor navigation and localization. But now we are coming to indoor navigation. And here, GPS has limitations when it comes to vertical localization inside buildings. What's the problem? GPS signals rarely make it through the thick walls of buildings. In these so-called GPS dead zones, you can also see here on the right side. The GPS signal is blocked and navigation information is not available. Also, GPS is not able to detect different floors. So what could be a solution? The floor level detection thanks to accurate altitude tracking, for example by means of a barometric pressure sensor. Here's an example. We call it BMP390, our new released barometric pressure sensor. Or you use a horizontal navigation system thanks to accurate positioning tracking, enabled by inertial sensors, for example here BHI 160 BP. Or you combine both. Pressure and motion sensors enable users to navigate inside buildings, for example in airports or parking lots. And for this we made some tests. You see here on the right side the GPS signal is a black line where you see the accuracy inside this parking lot is very, very limited. You have the mentioned GPS dead zones or very low accuracy when it comes to height detection. Only the green line here, barometric pressure sensor, can really detect the height changes inside the parking lot, inside the parking garage, and can really very easily detect when you're going up or down the stairs. Only pressure sensors can do that. No GPS is good enough because the accuracy is very low within buildings. And that was the reason for the FCC initiative for emergency calls in the US. Because this is now about indoor localization and only realized with barometric pressure sensors. What happened? The Federal Communications Commissions called FCC has been working with the public safety community and industry partners for several years now to define and ultimately obtain the vertical location information of emergency 911 callers in multi-story buildings. Recently, the vertical accuracy required for 911 calls was clarified when the FCC passed rules requiring wireless carriers to deliver Z-axis location information that is accurate within 3 meters for 80% of calls to the emergency dispatchers. This floor-level vertical location threshold must be met by April 2021, also next year, for the top 25 markets in the US, and by April 2023 for the top 50 markets. Besides, many potential solutions to overcome indoor location problems in localized environmental were considered, including Wi-Fi, RFID, low-energy Bluetooth, etc., none of which were able to achieve the vertical accuracy levels required today. However, the US-based company NextNav developed a dedicated altitude system that can provide FCC-required vertical accuracy across an entire metropolitan area. As a consequence, all smartphones will be equipped with barometric pressure sensors for the US market starting next year, which is surprising, because before a pressure sensor was not in all smartphones. More facts about indoor localization. Because what does it mean? So rescue teams lack sufficient information about the caller's location, as calls are often made with smartphones from indoors, where traditional localization technologies do not work efficiently or fail completely. I showed it before with GPS as an example. So the only solution, FCC requires wireless providers in the US to adopt a Z-axis location accuracy metric of ±3 meters relative to the handset for 80% of indoor wireless 911 calls starting in 2021. So very strict rules next year. And Bosch, with NextNav, a 3D geolocation service providers, have created a solution that provides highly accurate Z-axis capabilities indoors. So combining barometric pressure sensors inside smartphones with NextNav's Metropolitan Beacon System MBS Z-axis service determines 3-dimensional location and positioning for enhanced emergency calls, short E911. We have also more details here in the link I provided in my presentation. You can look at it afterwards. But very important that based on this solution, the FCC estimates that the additional vertical information has the potential to save up to 10,000 lives per year just in the US alone. This is an amazing number. So pressure sensor can help to save life. So more details about the usage of barometric pressure sensors for accurate indoor localization. This collaboration between Bosch and NextNav started some years ago. We are working together since 2013. It's a high innovative solution, a platform that localizes smartphones vertically and indoors by applying barometric pressure sensors and this NextNav's MBS technology. So rescue teams, forces can identify the precise altitude position of people in buildings now. You can save thousands of lives starting next year with this solution. And this is only the beginning. In short, here it's a sketch to explain this Metropolitan Beacon System called MBS, where you have reference devices on buildings in a city like San Francisco. So when now a smartphone user triggers an emergency call from a multi-story building, the MDS system localize the user, and the pressure sensor, for example, the BMP390, in combination with the MDS, delivers a vertical specific position, which enables first responders to determine the floor level. And this is now the key. This reduces the time it takes to precisely locate an emergency call, and this can save thousands of lives. What does it mean? Practically, it's shown here, because you can see here on the left side results of floor level detection when you're using this MPS. Because it overcomes some limitations, maybe you are aware of, for barometric pressure sensors. Because an altitude system is based on the fact that an atmospheric pressure sensor measures the weight of the column of air above a user that decreases with increasing elevation and rises when the altitude is decreased. But because air pressure is not static, but rather changes with weather, using barometric pressure for altitude needs to contemplate this fact. Ambient pressure can change in a few hours, which corresponds to ascending or descending more than 100 meters. So how can you then measure the exact altitude? The key to solve this issue is to measure the weather-induced changes in pressure at the same time at multiple fixed locations and use that information as a real-time reference with the pressure readings resulting from pressure changes on the smartphone. So you have a calibration of your pressure sensor by means of this MBS, these reference pressure sensors. So the weather-induced changes, and here you also include temperature differentials and other factors, can be subtracted, and the resulting difference in pressure corresponds to the altitude change of the users. So a lot of software and algorithms are also involved here. So improve altitude accuracy for a full metropolitan area. High accurate sensor readings are installed at the right heights, which are used to measure and ultimately compensate for changing weather conditions, including the effects of microclimates. The figure here on the left side shows a measurement with a smartphone, so a traditional smartphone which you can buy in every store, but with a Bosch SensorTech pressure sensor. So our technology is integrated. And the graph demonstrates how the Bosch sensor provides data which matches that of a high accuracy reference device. So high accuracy pressure sensor can help to meet the FCC regulation. And in fact, the consequence is that every smartphone which is sold in the US will have a pressure sensor. And the BMP390 will help meeting the FCC regulation. The order adopts a Z-axis location accuracy metric of plus minus 3 meters relative to the handset for 80% of indoor wireless 911 calls. These state-of-the-art sensors are also easy to integrate into smartphones, wearables due to its small size and low package height. And with this high accurate pressure sensors, you have only reduced efforts for high end-of-line calibration due to significantly improved absolute accuracy after soldering. Here you see our BMP390 in a picture. So it's a high-performance barometric pressure sensor for accurate altitude tracking applications, and this is realized, for example, for these emergency calls in smartphones in the US. You need a high accuracy to realize this solution. So it's needed, and it's realized with the BMP390, which shows significant improvements in relative absolute accuracy values, the temperature stability in average 0.6 Pascal per Kelvin, the drift behavior with high long-term stability, low short-term and long-term drift, and at a low noise level. So you can choose the BMP390 to realize this E911 solution. You have the best performance on the market due to the unique accuracy. More information on our product website. So then I come to the summary and give an outlook. So you learned today that indoor localization by means of barometric pressure sensors is mandatory in the US starting next year. And FCC estimates addition of vertical specific information could save up to 10,000 lives per year, an amazing number. Nevertheless, it's now a localized regulation inside the US for this market. It's also a huge market, but it has for sure the potential for a worldwide adoption. And similar approaches started already. There are initiatives in countries like European Union, in Asia, also to localize someone. And it's already mandatory outdoor. And it could also mean that in the coming years, it's mandatory indoor, like in the US. I presented the next step solution, but for sure there are also alternative solutions from companies like Google, which can provide accurate altitude estimation inside buildings. And when I present now indoor localization, the barometric pressure sensor is already in many smartphones, also worldwide, and has a potential to improve indoor navigation. And maybe there are new use cases when we now see the COVID-19 topic to trace someone in a building. So that's it from my side for today. I hope you liked it, and now we come to the discussion. Thank you very much for the attention, and stay safe and healthy. Thank you very much.